This video is a continuation of the last video on L'Hopital's rule, but on the last video, we evaluated a couple limits in which we could verify the validity of L'Hopital's rule using an algebraic technique. But we're going to take a look at some examples here where there's no other algebraic technique to use but L'Hopital's rule. So let's take a look at this first limit. As x is approaching 0 of sine x over x, and if we attempt to evaluate it at x is 0, we would have sine 0 divided by 0. And sine of 0 is 0. This result will give us 0 divided by 0, which is an indeterminate form. This allows us to use L'Hopital's rule. L'Hopital's rule, we would take the limit as x approaches 0, find the derivative of the numerator. Derivative of sine x is cosine x, divided by derivative of x, which is equal to 1. This allows us to reevaluate by plugging in the x is 0. Cosine of 0 is equal to 1. So this limit is approaching 1. L'Hopital's rule was the algebraic technique which allowed us to find it. We don't have any other algebraic technique to be able to do so. Let's take a look at this next limit. The limit as x goes to 0 of cosine x minus 1 over x. If we attempt to evaluate when x is 0, we would have cosine of 0 minus 1 over 0. And cosine of 0 is equal to 1. 1 minus 1 is equal to 0. This result becomes 0 divided by 0. Another indeterminate form. That means apply L'Hopital's rule here. Let's find the limit as x approaches 0. Take the derivative of the numerator. Derivative of cosine x minus 1 is equal to negative sine x. Divide by derivative of x, which is equal to 1. Then we can evaluate. Plug in the x value of 0. Sine of 0 is 0, and then multiplied by that negative up front is still equal to 0. So let's take a look at this first limit up top. The limit is approaching 1. The second limit is approaching 0. L'Hopital's rule allowed us to find that, but let's take a look at these two limits graphically now. The first limit, as x is approaching 0 of sine x over x, graphically you can see that the limit is approaching 1. This verifies L'Hopital's rule, which gave us the derivative of the numerator to denominator reevaluating at a limit as x approaching 0 gave us 1. The second limit as x is approaching 0 of cosine x minus 1 over x is approaching 0, and that verifies what L'Hopital's rule gave us as well. So for these particular limits, L'Hopital's rule was essential. We had no other algebraic technique but the graphical technique. Evaluating graphically, by taking a look at the graph, we were able to see where the limit was heading, but the only algebraic technique that we have available to us right now is now L'Hopital's rule.